The Earth is facing a defining moment. Rising global temperatures, melting ice caps, devastated forests, and increasingly extreme weather events signal what scientists have been warning for decades. We are in the midst of a climate emergency. Traditional measures, such as reducing greenhouse gas emissions, promoting renewable energy, and encouraging sustainable lifestyles, are absolutely crucial. Yet, they may no longer be enough to stop the rapid and catastrophic changes unfolding before our eyes. This desperate reality has led scientists, policymakers, and innovators to consider something once thought unthinkable: directly reprogramming nature itself to fight climate change. Imagine rewriting the genetic code of trees so they capture more carbon, altering ocean microorganisms to absorb CO2 at unprecedented levels, or even modifying the atmosphere to reflect sunlight away from the planet. These ideas belong to a field now known as climate bioengineering, or more broadly, geoengineering through biological intervention. At first glance, the concept seems both fascinating and terrifying. On one hand, humanity might finally wield the tools to correct the damage we've caused to the environment. On the other, tampering with Earth's natural systems at this scale risks unintended consequences that could spiral far beyond our control. As we embark on this exploration, one pressing question arises: are we ready to play God with nature? Should humanity take such bold steps, or are we opening Pandora's box, unleashing forces we may not be able to reverse? In this video, we'll explore what climate bioengineering actually means, the main techniques being studied, the potential benefits, and the enormous risks. Most importantly, we'll reflect on whether this is truly the path forward, or if it represents humanity's ultimate gamble with the planet's future. What is climate bioengineering? Climate bioengineering refers to the deliberate use of biological tools, such as genetic modification, synthetic biology, or ecological redesign, to combat the effects of climate change. Unlike conventional geoengineering, which often relies on large-scale mechanical or chemical interventions, bioengineering focuses on harnessing and reprogramming living systems. At its core, the idea is simple. If human activity has destabilized natural systems, perhaps we can now use our scientific knowledge to deliberately adjust those systems to restore balance. For example, just as humanity has modified crops to be more productive or resistant to disease, we might now modify forests to act as stronger carbon sinks, or design algae that capture carbon at rates far higher than their natural counterparts. Current proposals fall into several categories. Genetically engineered plants designed to absorb more CO2, store carbon more efficiently in roots, or reflect more sunlight with lighter-colored leaves. Engineered microorganisms, such as bacteria or algae, capable of capturing carbon dioxide, producing oxygen, or even breaking down methane. Ocean fertilization, where nutrients are added to stimulate plankton growth, which in turn absorbs CO2 from the atmosphere. Ecosystem reprogramming, where entire landscapes, forests, wetlands, or grasslands, are redesigned to serve as climate defense systems. While the concepts sound futuristic, research is already underway. Scientists have successfully engineered crops with deeper root systems to store more carbon underground. Synthetic biology companies are exploring microbes that eat greenhouse gases. Ocean experiments have tested whether adding iron dust could trigger plankton blooms to capture CO2. However, climate bioengineering is not simply about science. It's about power, responsibility, and risk. Changing the code of life, or manipulating entire ecosystems, is not just a technical challenge, it's a moral and political one. Who decides what should be altered? Who bears responsibility if something goes wrong? This brings us to the next point. How exactly might we reprogram nature to save the planet? Reprogramming nature, déterchiques in development. The vision of reprogramming nature to fight climate change involves multiple cutting-edge approaches. Let's look at some of the most prominent ones. Carbon supertrees. Scientists are experimenting with genetically modifying trees to enhance photosynthesis and root depth. Deeper roots could lock more carbon into the soil for centuries. Some designs also propose altering the leaf reflectivity of trees to bounce more sunlight back into space, cooling the surface. Synthetic microbes and carbon-eating bacteria. One of the boldest ideas is engineering bacteria that consume greenhouse gases like carbon dioxide or methane. These microbes could be released into soil, oceans, or even industrial settings. The challenge, of course, is ensuring they don't mutate or spread in harmful ways. Ocean reprogramming. The oceans absorb nearly 1/3 of human-produced CO2. Scientists propose fertilizing them with nutrients like iron to stimulate phytoplankton growth. These microscopic organisms absorb carbon during photosynthesis and, when they die, sink to the ocean floor, trapping carbon for millennia. Synthetic coral and resilient ecosystems. Coral reefs, often called the rainforests of the sea, are collapsing due to warming and acidification. Bioengineers are working on coral species genetically designed to withstand heat and acidity, effectively reprogramming marine ecosystems to survive in harsher climates. Atmospheric biointerventions. Though more speculative, some propose microorganisms that could float in the atmosphere, reflecting sunlight or capturing CO2 directly. This would essentially turn the atmosphere itself into a living climate shield. Each of these techniques is groundbreaking, but they raise difficult questions. What happens if modified organisms spread uncontrollably? Could altering one ecosystem trigger unexpected collapses in another? Are we trading one crisis for another, possibly more dangerous one? Promises and hopes. How bioengineering could save the planet. Supporters of climate bioengineering argue that we are running out of time. Even if humanity stopped emitting carbon tomorrow, global temperatures would continue to rise for decades due to the gases already in the atmosphere. Therefore, direct intervention may be humanity's only hope. The potential benefits are enormous. Rapid carbon reduction. Engineered trees and microbes could absorb greenhouse gases at rates far beyond natural capacity. Ecosystem revival. Reprogramming corals, forests, and wetlands could help ecosystems survive the pressures of climate change. Food security. Climate-resistant plants could secure agriculture in regions facing drought, floods, or shifting climates. Cooling the planet. Modifying ecosystems to reflect more sunlight or absorb more heat could directly stabilize global temperatures. Beyond science, bioengineering also represents a shift in mindset. It acknowledges that humanity is no longer just a passenger on Earth, but a geological force capable of reshaping the planet. If we have the power to destroy, perhaps we also have the power to repair. However, with such hope comes the shadow of risk. And here lies the great paradox. Can we trust ourselves to use this power wisely? Dangers, dilemmas, and ethical risks. The dangers of climate bioengineering are as immense as its promises. First, ecological unpredictability. Releasing engineered organisms could have unintended side effects, disrupting food chains, outcompeting natural species, or triggering irreversible changes. Second, moral hazard. If society believes bioengineering will solve the climate crisis, governments and corporations may feel less urgency to reduce emissions, worsening the underlying problem. Third, inequality and power. Who controls climate bioengineering? Wealthy nations and corporations could dominate, leaving poorer countries vulnerable to side effects they didn't choose. The technology could even be weaponized, deliberately altering climates as a form of geopolitical control. Fourth, ethics of playing God. Reprogramming nature forces us to ask if humanity has the right to alter life itself on such a scale. While we have engineered crops and medicines for centuries, changing the biosphere is a leap into the unknown. The risk isn't just technical, it's philosophical. Bioengineering asks us to confront what it means to coexist with nature. Are we caretakers, or are we conquerors who reshape life to serve our survival? Climate bioengineering sits at the crossroads of hope and fear. On one hand, it may represent humanity's last chance to prevent catastrophic climate collapse. On the other, it could unleash consequences we cannot predict or control. What makes this debate urgent is time. Climate change is accelerating, and traditional solutions may no longer suffice. The question is not whether bioengineering is possible. It already is. The real question is whether we should use it. Perhaps the ultimate answer lies in balance. We cannot abandon emissions reduction or sustainable living. Bioengineering, if used at all, should be a tool of last resort, guided by global cooperation, transparency, and ethical safeguards. At the heart of this dilemma is a reflection about ourselves. Humanity has always sought to bend nature to its will. But reprogramming the very building blocks of life to save the planet forces us to ask, do we truly understand the consequences of our actions? So, what do you think? Is climate bioengineering the salvation we desperately need, or the greatest gamble humanity could ever take? Share your thoughts in the comments below, and don't forget to subscribe for more deep dives into the future of science, ethics, and our planet.